Hello. 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 Am I audible, ma'am?
Yes, I can hear you. Thank you.
Uh, shall we start, ma'am?
Sure, sure, absolutely.
Thank you. Thank you. So, okay. Good morning, everyone. It's my pleasure to welcome you all to this webinar on functional safety. I would like to extend a warm welcome to our students, faculty who have taken the time to join us today. My name is Sai Durga, currently serving as Joint Section Representative for IEEE Vizag Bay section and also serving as Signal Processing Society Chair for Raghu Institute of Technology IEEE Student Branch. Today, we have a great speaker with us, Miss Jyotika ma'am. So get ready to learn and inspire. We hope that by this end of the webinar, you will gain valuable insights and knowledge that you can apply to your personal and professional life. I thank Chaudhary sir, Samir sir, and all the faculty for encouraging us to do this kind of activities. Without further ado, let's start with the introduction of our speaker. Now I request Sai Harshni to go ahead.
Is president elect of the IEEE committee leader and influence emerging tech and international standardization. She was awarded the IEEE Community Society Golden Core Award in 2022. There's the IEEE 851 standard on functional safety and interoperability. With over 25 years of industry experience, Jyotika ma'am is currently a senior technical NVIDIA and is driving capability development, safety architectures, and methodologies. Safety engineering activities and pathfinding for markets such as autonomous driving and to NVIDIA. She was principal director at Intel Corporation, where she led functional platform architectures for and avionics phases and raw methodologies for radiation effects modeling and product qualification activities. Jyotika ma'am is an active member of the IEEE Society Functional Safety Standards Committee and Automation Standards Committee and Diversity and Committee. In addition, she represents the Computer Society at the IEEE USA AI Policy Committee, IEEE SA Industry Connection Group on Mobility as a Service (MAAS) related standardization activities, the IEEE Women and Engineering Committee, IEEE Systems Council. Last year, she served on the IEEE Computer Society Industry Engagement Committee and Audit Committee. Outside the IEEE, Jyotika ma'am is actively in several international initiatives on ISO, SAE, and UL. She also served further patents and many technical publications in IEEE conferences and journals. She received her MS degree in electrical engineering in 1990 from Iowa State University. Thank you.
Now I request Miss Jyotika ma'am to start our event.
Great. Thank you so much for the kind introduction, and it was a pleasure to be here today. Thank you, Sai Durga, for inviting me. I really appreciate it. And first of all, I just wanted to convey my congratulations to you all for organizing the event and for taking the initiative to, do these talks. I think it's a great way to disseminate information among the students in the university and have this interactive session for discussion on new technological areas. So thank you so much for organizing and also for the invitation. I'll go ahead and share my slides here. You can hear me okay?
Yes, ma'am.
Okay, perfect. Here's slides. Um, and so, as I mentioned, the topic that I chose for the talk today is on functional safety, just because this is a topic that I work on in my day-to-day job, and is one that I have the most experience in, related to also dependability, which is kind of a term used more holistically to cover a spectrum of technologies, including functional safety, together with reliability, availability, maintainability, real time, and cybersecurity as well. Um, it's part of the IEEE Computer Society. There are many ways in which you can engage and volunteer and, drive activities or participate in activities. And standardization is one of those activities that I've been very closely involved with. There are other ways to engage with the Computer Society, such as conferences, there's publications, there's chapter activities, there's collaborative research areas between industry and academia. So there's a lot of ways in which you can engage and participate and volunteer your time. And I really encourage you to look at our website and look at all of those different activities that IEEE Computer Society has to offer, and then find the one that you are most interested in and pursue that. But anyway, with respect to functional safety, the topic that I chose for the talk is on a working group that I'm driving related to functional safety interoperability, and that is the IEEE P2851. This is the name of the project. This is a standardization initiative that was kicked off in early 2020. The project authorization request, or the PAR, was approved in late 2019. And right now, this working group is still active. The P2851 represents a family of standards, and so currently we are working on the development of one of the base standard drafts, which is close to publication. And I'll talk about what that draft contains, and kind of how we went about kicking off this initiative, and we can talk about the functional safety life cycle. And I'd invite you to ask me any questions or comments at the end of the talk, and I really want to have hear your thoughts, and really excited to have that conversation with you. So anyway, so we'll jump right into it then. IEEE P2851 is the standard for functional safety data format for interoperability within the dependability lifecycle. And the first slide that I have here talks a little bit about the role of IEEE in standards versus the other SDOs, or the other standard development organizations. So as you probably are aware, we have an overarching organization, IEEE, called IEEE SA, or the IEEE Standards Association, that oversees all of the standards development across various technologies. Um, and then within IEEE, there's also various societies that are focusing on specific topics. The Computer Society is the largest society within IEEE, and a lot of these standardization initiatives are sponsored, from the Computer Society, and then we work in close collaboration with IEEE SA. So the standard I'll talk about to today is one of those standards as well that was, born, so to speak, from the Computer Society and evolved and is now, working on publication here fairly soon, where we work very very closely with the IEEE SA staff, who helps and supports the work. So, if you look at all of these different standards that IEEE is involved in, there are certain topics, certain technologies in which IEEE has more of a leading role, a governing role, or, as the mainstream SDO. There are other technological areas, functional safety is one of them, where IEEE has, kind of a supporting role, right? So there are other governing mainstream SDOs like ISO, like SAE, like IEC, which have traditionally been driving standardization in functional safety. And so this slide basically serves to show what is the role of IEEE with respect to other safety standards, because this question often comes up is, are we trying to drive something new? Are we trying to do something that conflicts with the work that is being driven out of ISO and IEC? And the answer is no, right? So we are trying to do initiatives and things to support and to maintain full alignment with those mainstream standards. IEEE plays more of a supporting role, as I mentioned. Some of the things that we focus on with our standards is provide implementation guidance. So what that means is, if you take a standard like ISO 26262, which is the functional safety standard for automotive, the standard provides all of the objectives and requirements that one needs to comply with when implementing the safety engineering work, but it does not provide the low-level details in the implementation guidance, and that's where a standard like P2851 comes in, where we work on defining methodologies, defining the data models to implement those requirements. Then we support interoperability, such as P2851. What interoperability means here is facilitating the data exchange across the boundaries, right? And so those boundaries could be application boundaries, going from one safety critical domain to another safety critical domain, like automotive to industrial, or industrial to medical to avionics. So as you traverse those boundaries, how can you ease the data exchange across those applications? Because for functional safety, we do have governing standards defined for each domain. So like you have the ISO 26262 for automotive, you have another standard for industrial, which is the IEC 61508, and then you have other standards for medical and avionics. For avionics, we have the DO 254 and the DO 178C. So, since we have these specific standards for each domain, each standard dictates its own set of requirements, and then the safety engineering work becomes very domain specific, so to speak, and it's not easy to reuse that data across the boundaries. And that's where P2851 is coming in, where we are working to drive a common framework within which you will have requirements that support interoperability. So, have common methodologies, common tools and databases and data description languages to help facilitate that data across the domains. And then we also talk about interoperability in other aspects, such as interoperability across levels and across technologies. Um, the other things we do are, overarching aspects or cover standardization gaps. So, as we are becoming as we are working towards, the technology for autonomous driving and, all things autonomous, like autonomous mobile robots, etc., there are a lot of aspects of functional safety that need to be considered, the interaction with other technologies, looking at, the functional safety with respect to cybersecurity, with respect to SOTIF, looking at the dependability view. And there's aspects in hardware and software, aspects with respect to AI, etc. And so there's specific topics and problem statements that need to be resolved. And so we do work on covering those standardization gaps that in those topics which are not covered, say by the mainstream SDOs like ISO and IEC. And so what you're seeing here in the rectangles on the left are, those basic standards, generic standards, and specific standards that are kind of exploding now with the, evolution of functional safety. We also have formed actually a standards committee that oversees all of these different working groups and kind of works as a harvesting, committee to help grow standardization initiatives for new topics and new problem statements that we are researching, in that committee. So that's the IEEE role with respect to safety. Now, not to say that we are in a supporting role for every technology, because there are technologies where IEEE is the mainstream or the go-to or the governing SDO. So, we do keep our leadership. We do maintain our leadership in those technologies, but at the same time, we want to continue to foster and support, other technologies with, having this strong partnership or link with other SDOs, having the liaisons with them, and working very closely. In fact, P2851 is one standard where, we are working very closely with ISO. All right, so here's a little bit more about the problem statement that we worked on. So um, before, we wrote up the project authorization request for P2851, there was a special technical community that was kicked off in 2019 on these dependable technologies. And in fact, when we had that, inaugural event for the STC, uh, we were brainstorming different problem statements, and that's when, this problem statement was noted. And so that STC, for, reliable, safe, secure, time deterministic intelligent systems, actually served as a sponsor of the P2851 standard. And what we brainstormed there was exactly this interoperability topic with respect to dependability, that we just talked about on the previous page. And the issue was, today, the way, the mainstream standards are interpreted and executed or implemented by each company is very company specific. So if you take an IP provider, if you take a chip vendor, or if you take an EDA or tools company, they all have certain aspects of functional safety with respect to ISO 26262 for automotive that they need to implement. But because there isn't common implementation guidance, each company kind of interprets the standard in their own way. There's just high level requirements. So that was one issue. And so that exchange of data in the whole ecosystem becomes very difficult, because say I take some safety analysis data from an IP provider like ARM, and then I take all of their FMEDA data and I want to integrate it into my chip level, my SOC level safety analysis. It's not easy to integrate it if there is no common, description language or data format or template. And so that, provides additional overhead. So that's expensive in terms of time, resources, to integrate. It's a lot of heavy lifting to do that as you move upstream, from an SOC to a module developer, and then later on to the item at the OEM. This same issue is seen in terms of the integration and reconsolidation of data. So having a common language, having a common set of methodologies and formats was something that, we saw as a lot of value add to, help with this, streamlining this whole safety engineering process across the value chain, whether it's an automotive value chain or whether it's for industrial robotics or for medical avionics, etc. It's the same concept and the same problem statement. So the scope of it really spanned across those domains, application domains, and also spanned across levels. And then the other problem statement was, what about the interoperability between technologies? Because, if you have a safety critical system where, you need to comply with certain safety integrity levels, you also have certain requirements for cybersecurity. You have certain requirements for reliability and as well as for, interference analysis or real time. And so in order to take into account all of those requirements and implement those requirements with a holistic architecture, you need to consider those trade-offs, and you need to consider how you can come up with a common set of mitigations to address the needs of all of those individual technologies. And so that was the other kind of interoperability that we needed to consider, is functional safety with respect to these other adjacent technologies that constitute dependability as a whole. So anyway, so P2851 was kicked off in 2020, at the beginning of the year, and we have about 30 companies that are today part of the working group, about over 70 active individuals. Some of these companies are voting members, meaning they are IEEE SA advanced members. And then there are some companies that are, observers or basic members. Today, to be a basic member, of IEEE SA, it's free of cost. So there is no, any company can join and participate as an observer. If the company wants to participate more actively, like have voting rights, have being able to contribute to the content of the draft, have access to iMeet, where we have all of our documents and repository, then they can get advanced membership where there is a fee associated with that. Now, this is an example of a working group, which is an entity-based working group, meaning that, each company is an individual participant, but there are other working groups within IEEE Computer Society that are individual based. So say, as a member, you are an IEEE member, and your entity, say, so to speak, your university or your company, is not really a member of the IEEE SA, you can still participate as an individual member in those other, working groups, which are, individual based, like there's standards working groups like the P1228, there's the Functional Safety Standards Committee, and there are several others that are individual based as well. So some of the working groups are individual based and some are entity based. Also, the structure is that every working group has a chair, vice chair, a secretary, and a program manager. In the case of P2851, uh, besides myself, I serve as chair. There is vice chair from Qualcomm. His name is Neil Mauer. And then there is the secretary, Werin Chen from SGS2. And then we also have the IEEE SA program manager, that is Jonathan Goldberg. All right, so this slide here, which is one that we also included within our draft of the base standard of P2851, talks a little bit about the same problem statement that I already shared. So I, won't talk in too much detail, but just to show from an for illustration, here's all of the different safety critical domains, right? So we have the automotive, we have the industrial robotics and also machinery, and then we have the aerospace or the avionics standards, and they're all safety critical. They all have requirements that we need to comply with, for our systems. And then in the bubbles here, you see the mainstream of the governing standards. For example, for automotive, we have the ISO 26262, for functional safety, and then we have the SOTIF standard, the ISO 21448, and then we have, the UL 4600. Similarly, we have standards for these safety critical domains as well. And you're seeing this interoperability or exchange chaos here across the boundaries, where we don't have, that common framework for the data exchange. So for example, if I build a safety case, for automotive, complying with the V model in the ISO 26262, that safety case or that set of work products or documents that are produced as the result of my safety analysis, safety engineering work cannot be reused for, robotics or for avionics because they have differing requirements. So how do we fix that? And that's where, we came up with this proposal for IEEE P2851 to serve as that glue, that connects these different application domains and serves to provide that common way in which the data can be exchanged by defining data models and description languages, methodologies, tools, and databases that, for various topics. So in P2851 in the base standard, we focus on a domain agnostic dependability life cycle. I'll talk about that in the next slide. And then within that life cycle, we have divided that life cycle into different phases that span across the product development, going all the way from concept, through the architecture and design phases, the verification phases, and then, the certification and production and post-production as well. And so through each phase, we have identified certain topics that are critical for interoperability. And then we, include requirements and implementation guidance for each one of those topics. Um, so here's, kind of that dependability life cycle concept that we introduced in a white paper that was published in June of 2021 um, in IEEE Explore. And so that was the first, deliverable from the working group is to publish this, introduction to a dependability life cycle. And because we maintain complete alignment with mainstream standards like ISO 26262, what you're seeing here is the V model, that is from the ISO 26262 standard, and that we use that as reference. What you see here in this V model represents, all of the activities that a safety engineer would need to execute as you traverse the safety engineering process, whether it's an item or a system or a component or an IP, all the way from the design activities, that's the left side of the V, and the verification activities on the right side of the V. And then here you're seeing in the center is the data format. So we'd like to have this common data format to facilitate the data exchange, within a level and also across level. So, right, so that's intra level as well as inter level. What that means is exactly what we talked about on the previous slide is, say I have, some safety data that came with my IP or part, and I want to integrate that IP on my SoC or system and chip. I need to make sure that that data is easily exchangeable. And then if I have my component level artifacts that I want to integrate into my module or system, then that data should be easily exchanged as well because it needs to have a common language to exchange that data, and similarly all the way to the item level. Now in each activity, and these activities represent, safety engineering activities related to product development. For each activity, there are certain tools and there are certain methods that need methodologies that need to be executed. And then within those tools and methodologies, that's where, the interoperability has to be considered. So we'll talk about some examples on the next page, but this was kind of the overall idea. And then on the left here was kind of one way, an example of, staggering all of the different dependable technologies for a given activity, to consider that interoperability between technologies, right? So, for example, you start out with the functional requirements, for a given product. Then you consider the performance or availability requirements and those implications. Then you consider what are the reliability requirements and how do those affect my system, and how do those need to be implemented and considered. And then you consider your functional safety of the intended functionality requirements, and then the cybersecurity requirements. And then at each step, you need to consider the trade-offs that you need to make in order to consider, one set of requirements with the other, such that those requirements don't conflict, and you can implement a solution that meets both sets of requirements. So that trade-off is kind of an iterative process that you need to follow with a few iterations before you come up with a common approach to address the needs of every technology. And you would need to do this kind of iteration through activity by activity through the entire safety engineering life cycle. So that was one example that's introduced in the white paper. And then we build on it, of course, in the standard. The standard is not published yet, but it will be published in summer of this year. And so, there is, detailed guidance on how to consider these dependable technologies and address the interoperability between them, and also facilitate the data exchange across the application domains. So here's another view of the same kind of idea. This is the dependability lifecycle disk. So you see, you're looking at product dependability as a whole, and from a functional safety lens, because we are really focusing on the safety engineering work. But as we execute those activities, we consider implications from cybersecurity, the function, performance, reliability, behavioral safety, etc. And so, it's that iteration that you need to perform, traversing all of the activities related to design, which is all of these activities here: design, V&V, integration, and validation as well. And so all of the work products that are generated, the reports that are generated as a result of that safety engineering work, analysis, verification work, should be done in that interoperable way, or should be executed in that interoperable way. So this notion of the dependability disk and the dual cone V model was also published in the IEEE Computer Society magazine last year. It was as an article, and also is now part of the base standard, in one of our annexes. So this is kind of related to the V model that we just saw from ISO 26262, but we call it the dual cone V model for dependability. And it includes within it, each of the individual elements that you need to consider in the overall system, including the hardware and software components, the SoC subsystem, the EE system, network, overall system, and the operational domain. And then you see this concentric view, within that dual cone, where you consider the implications of each one of the technologies that we talked about, as those concentric circles at each level. So that was just another way to represent the dependability concept. And then, here's the examples. So when we kicked off the P2851 working group, we split up into 6 different subgroups. These subgroups represented, different aspects of functional safety to consider. So we had one subgroup focusing on, problem statements related to automotive functional safety specifically. Another one looking at, safe AI topics. Another one looking at industrial and medical safety related topics. Another one was focused on avionics. And then there was one on SOTIF, or safety of the intended functionality, and then one on safety and cybersecurity. And then each one of these subgroups, met together and brainstormed the different topics that need to be considered, within their specific area, or specific to the scope of that subgroup. And so that's how we collected all of these different topics. We combined the topics from each of the subgroups, and we came up with a list of about 108 different needs or requirements where interoperability needs to be considered. So in the white paper that we published in June in 2021, in the annex of that white paper, you'll find a list of all of those 108 different needs. But I included a few of those here, just for as examples. So here's examples of some of those needs in terms of DL, ME, and DB, or description language, methodology, and database. The description language examples are the safety plan, safety case, confirmation measures, description language for external measures, for description language for calculating base failure rate, and then methodologies for executing certain aspects of the safety analysis, such as, what is the methodology for requirements evaluation? What is the methodology for modeling and measuring vulnerability factors like architectural vulnerability, time vulnerability, program vulnerability? How do you do dependent failure analysis? What is the methodology for ASIL decomposition, etc. And then, also examples for databases. So these are just few examples to kind of give you a flavor of the kind of topics that, the members of the working group came up with. As I said, there's a total of 108 or so topics that are now organized, in the base standard by phases. So each phase of the life cycle, has specific topics associated with that phase of, the work that needs to be done during the product development. Okay, so then, a little bit more about the safety activities within IEEE Computer Society. We also have an overarching committee now. It's called the Functional Safety Standards Committee that oversees, all the working groups that are driving, standardization related to functional safety or related to dependability. And so there's other working groups like the P1228, P2846, etc., that are part of the Functional Safety Standards Committee umbrella. And this is an example of those individual-based committees where anyone with an interest in functional safety who is an IEEE member can join. The FSSC can participate. There are certain study groups that are being driven out of FSSC, where people go ahead and research and brainstorm certain problem statements in the study group, and then eventually that study group can evolve into a working group if they write up a project authorization request that is approved by the committee and by IEEE SA. So we just had one recently on STPA, another working group that was formed. And there are some other study groups, that are quite mature in terms of their problem statement, that are also progressing in that direction. So with respect to P2851 roadmap, I just wanted to share what we are doing here. So this is more of, schedule type of aspects, but this just says that we are working on the base standard, the first revision, which is the domain agnostic dependability lifecycle. That revision will be released this summer. Then we will work on, subsequent revisions for domain specific life cycles for automotive, industrial, medical, avionics, which will be, the next level detail. And those will be included in the annexes of the base of the first revision of the base standard. And we plan to kick off that work in the end of this year. And then also, because this is a family of standards, we will have derivative standards or dot standards. Um, and those dot standards will have, implement some of the key topics that we identified. So for example, we say, vulnerability factor methodology is a topic where interoperability needs to be considered. It's one of the requirements in P2851. So how do you, measure or model vulnerability factors such that those are interoperable across the domains? So that implementation, that methodology, maybe there's fault injection, analysis methods, or other aspects. All of those, that implementation will be covered in the DOT standards. And also in the DOT standards, we will include the work that is being done by some of the other functional safety groups that we have a liaison with, such as Accelera. Accelera is another SDO that has a functional safety working group where they are working on, similar aspects related to interoperability. And so their work will also be published as part of P2851 in the DOT standards. So that was, in a nutshell, what I wanted to share with you all today on functional safety interoperability. I also just wanted to thank you all for listening and for participating today. I'm really grateful for all of the effort and all of the great initiative, to organize the session and to drive this discussion. So thank you so much for doing that, and I'll be happy to take any questions. Stop sharing.
Thank you, ma'am. Just a minute. Okay, now we will close. So, okay. Is anyone like to ask some questions? I'm unmuting all. You can unmute yourself and ask our speaker questions about our topic. Yeah, I have changed the settings, so you can unmute yourself and ask questions.
I was on mute. Any questions from anyone?
A very good morning, ma'am.
Hello.
I have a question, ma'am. Am I audible, ma'am?
Yes, yes, absolutely. Thank you.
Can you share some real world examples of how functional safety has prevented accidents or failures, maybe in a real world environment or any industries, ma'am?
Yeah, absolutely. So, the main concept of functional safety is to avoid a catastrophic hazard from happening, right? And so, for example, in autonomous driving as well as in autonomous mobile robots, there are certain requirements for functional safety that you need to comply with depending on the safety integrity level. So, like if you have a safety of ASIL D, where ASIL stands for automotive safety integrity level, then you need to meet a certain level of, you need to your system needs to meet a certain fit rate requirement, needs to have a certain amount of diagnostic coverage, etc. So for autonomous driving, functional safety is extremely important. The highest levels of safety integrity need to be met for autonomous mobile robots, maybe all kinds of robots used in industrial floors, or for surgical robots, or others for inventory. There's safety requirements there with respect to SIL, safety integrity level, per the IEC 61508. And then if you look at avionics, safety critical systems, flight control, engine control, cockpit display type systems, there's DAL, design assurance level requirements that you need to meet as well. So they are very similar in terms of, the kind of metrics that you need to meet in these, autonomous systems. There's just, specific standards today with requirements for each of those different kinds of systems and their use cases that need to be considered when you are, implementing your mitigations in your system to comply with those requirements. Did that address your question, Divya?
Thank you. Thank you. It was clear, ma'am. Thank you.
You're welcome. Any other questions?
How can students career in practical?
There's another question, but I can't really hear.
How can students who are pursuing practical?
Hi, are you able to hear the question? Maybe you can repeat it.
Her question is, just a minute, ma'am. I will check once again with her. Her question is, how can students who are in pursuing a career in functional safety get involved and gain practical expectation in this field?
Yeah, no, it's a great question. I think there's different ways in which you can do that. I think as a student, um, in university, the best way to do that, besides of course your academic work, if you have taken any courses or any such thing in functional safety, is maybe you can pursue some projects, or some research projects on campus or in collaboration, even with an industry, a company in the industry, or another university. So do some kind of maybe collaborative research projects on functional safety and for a given use case would be great. Um, present, maybe submit your work at conference, and look for opportunities there to share your results, and publish your work, if you have something interesting in terms of your research that you can write up and submit at some of the key conferences. um, and of course, as I mentioned, standards, but standards, the ones that are individual based are those working groups where you could potentially join and participate. Usually we do have a lot of people there from industry, but also some people from academia, um, some researchers who are part of that. The P2851 is an example of entity-based where only companies participate, but there are other standardization initiatives. There are special technical communities, that focus on specific technologies, that you can join, and they will, share, get added to their distribution, because, they will share their work. Often they would, also host webinars where, and you would have some key experts come in and share talks. So there's a whole variety of ways in which you can engage in functional safety. There's a lot of also today on social media, there's certain threads that you can follow and get more information. But feel free to reach out, and I'll be happy to chat more, and share my ideas there as well.
Thank you very much.
Welcome.
Good morning, ma'am. My name is
Hello.
Dinesh. I'm from third year. I have a question, ma'am. What sparked your interest in functional safety and how did you get started in this field, ma'am?
That's a great question. Yeah, thank you for asking. So it's very interesting because, my career did not start in functional safety. In fact, I started my career in EDA, doing mixed signal simulation tool development, and then that was at Synopsys. And then when I joined Intel, I joined in the reliability group. So I spent a lot of my time in technology manufacturing, doing, reliability qualification, reliability architecture, etc. And then in 2015, 2016 timeframe is when I started to get more involved in functional safety, just because Intel, acquired a company, Yogitech, that was doing some pathfinding work in functional safety, and Intel wanted to focus on functional safety. So you remember when I was talking about dependability in the presentation, the dependable technologies are technologies like reliability, functional safety, cybersecurity, real time, where they have very similar requirements, similar, mitigations, implementations. And so from that standpoint, reliability and functional safety are kind of like sister technologies. And so as we acquired Yogitech, I was, asked to drive those concepts and those methods, and integrate them in Intel, and that's how I got involved in functional safety. So that was my career path, I guess, and then since then I've been involved with the field.
Thank you. It's inspiring, ma'am.
Thank you. Thanks for the question.
This is I again. I do have a question also.
Sure.
It is how does functional safety relate to cyber security, and what measures can be taken to ensure both safety and security?
Yeah, no, it's a great question. So there this is actually part of our work in B2851 as well, where we are proposing a flow, which would work for these systems where you have safety requirements, but then you also have to consider cybersecurity requirements. And so, how do you define activities that would work in tandem and would address the requirements for each of these? So, for example, in safety, you do something called a HARA, like a hazard and risk assessment, very early on, where depending on your use case, you define, what is the severity, exposure, controllability, and defined a safety integrity level for your component. Similarly, in security, cybersecurity, there's something called TARA, or a threat analysis that is done. And so, we define this flow, which shows all of the safety related activities lined up with the security related activities, and which are those points where we need to sync, say, consider, the results from TARA when you're doing the hazard risk analysis and vice versa, and so on. So that's just an example. But in the annex of P2851, we have proposed a flow, which shows, how to consider the alignment between safety and security, just walking through all of these activities through the product development. And you'll find that a lot of the mitigations are common. So for example, for cybersecurity, some of the ways in which you can mitigate or implement mitigation is things like partitioning and separation. Those are also ways in which you can achieve functional safety. So today in work that we do, for example, in our product development and our chip design, we have certain architectural mitigations that we implement for security, but then those are also applicable to functional safety. So there's a lot of synergies as you go through the mitigations, but it's very important to consider the requirements as you execute each phase, because sometimes you have to consider the trade-offs as well. And so that's safety security flow, as I was mentioning, that you can refer to in our annex, defines that detailed flow and the considerations that you will need to take into account when you want to execute your safety engineering work while comprehending the needs from security. And so once we publish the standard, which is this summer, you will have access to that, and you can then refer to that. But today there's also some other parallel work happening. For example, there's another standard, the ISO TS 5083, which also covers some aspects of safety security as well. And then there is the Functional Safety Standards Committee has published a recent white paper which has kind of this mind map of all of the different standards for all the different areas, including safety and security, and tells you, the references and where you can go get more information for, depending on, if you're looking at implementation at the lower levels versus, at item level, for example.
Yeah, thank you, ma'am. It is very informative. Now we will end this session, end this webinar with a vote of thanks. Before that, I request all the participants to turn on your camera. We will take a quick snap and end our webinar. So I request all the participants attended to turn on your camera.
Very good.
Okay, thank you. Thank you. You can turn off your camera. Now our student, uh, Sanjusha will give vote of thanks. Sanjusha, you can unmute yourself. Ma'am, can you hear her? Hello? Is she audible, ma'am?
No, I can't hear anything. Sorry.
Ma'am, okay, let me check it.
That's all right. It's okay.
Dear participants, good morning, everyone. This is Sanjusha. I'm currently in my second year CSC department. Firstly, I would like to thank our Vice Principal, sir, and backbone of our IEEE, Dr. P. Satish Ramachaudhary Garu, for being a constant inspiration. Secondly, I would like to thank our branch counselor, Dr. Samir Garu, for always encouraging us to take new steps and taking care of each and every event we have been part of. If we wouldn't be there would be no successful event that have been contributed. And our heartfelt gratitude goes to the esteemed speaker Jyotika ma'am for sharing their valuable insights and knowledge on the topic. Our speaker is well-deserved expert in the field of functional safety and has several years of experience in this domain. Her expertise and knowledge on the subject have helped many organizations achieve safety standards which have informative and enlightening. We are grateful for their time and efforts in making their event a success. Ma'am, our webinar was huge success. Our students really enjoyed our presentation and interaction with them. I also thank Ramesh sir, Radhika ma'am, and Adinarayana sir, HOD of CS department, for always guiding to the content. It was because of them we could gather a lot of intelligent minds like you to be a main contribution to this IEEE. Also, I would like to thank our IEEE members. Each and every IEEE member has their own significance. It was such an incredible experience and journey toward being from interaction with different mindsets and people to successful hosting the events. Finally, I would thank each and every student sitting here and connect from their home and workplaces viewing this event so patiently and taking it to new heights. Thank you.
Thank you so much. Thank you for organizing and thanks for having me. I really appreciate it.
Yeah, thank you, ma'am. We can end the meet. Thank you.
Thanks.